Technology in Focus, highlighting the amazing research and technology that are open to investors. Learn about it here at the UNT Murphy Center for Entrepreneurship and Innovation.
My name is Vahid Hasannaeimi. I obtained my PhD in Material Science and Engineering from the University of North Texas in 2019. And then I studied electrochemical and catalytic behavior of metallic glasses. I'm currently a postdoc associate in the Department of Material Science and Engineering at UNT. And I'm working on surface degradation mechanism in materials, functional and structural coatings development, and corrosion mechanism in multi-phase alloys. And about my advisor, who is Dr. Sandeep Mukherjee, is currently an associate professor in the Department of Material Science and Engineering at UNT, and he has published many papers in the area of like alloy development, mechanical and electrochemical degradation of alloys. And like his research interests mainly I can summarize as like structure property relationships in metallic glasses and high entropy alloys. So the main problem for this technology that we are proposing is that the azo dyes are generated from industrial waste at high levels, and they have created an alarming threat as toxic water pollutants. They can cause like neurological disorders, cancers in human body, and they are very harmful for human health. So some like many elements and alloys and materials have been proposed to degrade these azo dyes from the water resources to purify the water. Some of these elements and materials are like based on nickel and iron and noble metals, but all of them have some like problems. They have good catalytic behavior. They typically are efficient in degrading the water pollutants, but they also have like some problems itself. Like some of them are harmful to human bodies. Some of them, like noble metals that are currently used, are very expensive and scarce. So we want some technology that is cost effective and can last for a longer time. Metallic glasses are amorphous multi-component materials that have attracted a lot of interest due to their high catalytic activity, chemical stability, and durability. They are very corrosion resistant and they have excellent mechanical properties. So the excellent catalytic activity of these alloys initiate from the disordered atomic structure and a high density dispersion of catalytic active site over the surface. So they are very reactive in degrading the azo dyes. We think about this. And then we propose using an aluminum-based metallic glass powder as an alternative for azo dye degradation in water. The powder contains iron and nickel, which are, in addition to aluminum, which are like three of them are somehow catalytically active. And then moreover, metallic glass powder showed a great chemical stability and durability, and it can be used for higher cycles compared with the conventional metal catalyst. So as mentioned in my previous discussions, like the proposed powders is aluminum-based metallic glass and has different atomic microstructure with the conventional catalysts, which are crystalline and or has ordered structure. So the disordered structure of the current technology will help raising the catalytic performance of the metallic glass, since almost all atoms on the surface can participate in these catalytic reactions and can be an active site. And also the amorphous catalysts have much higher chemical stability and corrosion resistance, as I mentioned, and they can be used for higher number of cycles. This will save a huge amount of catalyst consumption compared with conventional catalysts. This technology has a great potential for mass production to be used in water purification industry, like partnership through licensing the patent to a chemical company or governmental firm could be a promising route for this technology. And a future insight, like any other project that we have in the lab, is like investment for starting a startup and production this technology at larger scales with a collaboration with a industry partner. So for that we are like working on writing a proposal as a like SBIR, NSF SBIR for small businesses proposal to be submitted to NSF, and this will help us to also go ahead and like obtain the regulations and certification required for somehow like certifying this technology to be used in water purification industry.